Assalamualaikum warahmatullahi wabarakatuh. A very good day I bid to Madam Husnaini, whom is our beloved lecturer for the subject Electrical Technology, BEEY 2353. My name is Ahmad Fikry and I would like to introduce my fellow teammates of Group X, Mohamad Firdaus bin Othaman, Muhammad Ajrun bin Zaimon, Cik Manshorsamsudin bin Cik Shamsirudin, and Arif Ridzuan bin Mustafa Jaafar, whom dedicates their valuable time and energy in the making of this slide presentation. Many thanks to you all, friend. As for the stars, we have been assigned with a parallel RLC circuit in resonance state. So, what is parallel resonance in RLC circuit really means? Resonance, in other words, it means synchronization. So, to put it simple, resonance is causing the sound waves to be clear and loud in a synchronized form. So, when you set up the parallel RLC circuit, it will give us the resonance that results when circuit elements, which are resistor, inductor, and capacitor, are connected with their inductance and capacitance in parallel, so that the inductive reactance and the capacitive reactance are equal and obtain maximum impedance at the frequency at which the circuit is resonant. Now let's moving on to our first point of this presentation. A parallel resonance will be produced by a parallel circuit with the resistance R, inductance L, and capacitance C. Second point is the magnetic field of the inductor and the electric field of the capacitor serve as energy storage device in a parallel resonance circuit. So, by based on the circuit shown just now, there is no current and no energy being drawn from the supply because this energy is constantly being transferred between the inductor and capacitor. This is because the corresponding instantaneous values of current at inductor and current at capacitor will always be equal and opposite, and therefore the current drawn from the supply is the vector addition of these two currents and the current flowing in IR. We can use the supply voltage as our reference vector because we know that it is shared by all branches when solving AC parallel resonance circuits. As with series circuits, each parallel branch must be handled separately in order for the total supply current drawn by the parallel circuit to be equal to the vector addition of the currents drawn in each individual branch. Then I will pass on the discussion of our presentation to my friend Firdaus with further elaboration. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Firdaus. I will talk about the how to using the multi-sim simulation software. First of all, construct the circuit in figure 1 using the multi-sim simulation software. Second, create the new file, then select the component that using in the circuit. Third is select the components such as resistor, capacitor, and inductor, and signal generator. After that, the value of resistor is 7.85 ohm. For the capacitor is 162.11 pH. For the inductor is 100 microfarad. For the function generator is 1.25 megahertz and 10 VP. Then save the circuit, then click run button. After that, record the value of phase difference between Vs and It, current through resistor, current through capacitor, current through inductor, average power, and power factor. Join the simulation result and attach the calculation for the circuits.
Assalamualaikum. My name is Arif Mustafa Jaafar. Today I want to talk about the calculation of parallel RLC circuit in resonance state. As we can see, the resistance is 7.85 ohm. The inductor is 100 microhenry and the capacitor is 162.11 picofarad. First, we calculate the resonant frequency. F equal to 1 over 2 pi square root LC, and we get 1.25 megahertz. Then we calculate the inductive resistance SL 2 pi F. The formula is 2 pi FL. Then we got 785.398 ohm. Capacity. Then we calculate the capacitive reactance as SC 1/2 pi FL. We got 785.417 ohm. After that, we want to find current through. First we calculate the current through R, IR. We use Ohm's law. So current through R is the voltage that we have here, 10 volt. So V over R, 10 volt over 7.85 ohm, that we got 1.274 current through R. Then we calculate the current through L, inductor. IL equal to V over SL. So we got 0.013 ampere. Then we calculate the current through C, V over SC equal to 10 V over SC, 10 over 785.417 ohm. We got 0.013. We assume that current in parallel resonant circuit current are equal. IL equal to IC. Then we calculate the total current IT equal to square root IR square plus IL minus IC square. So we got 1.274 amp. The same like current through resistance. Yeah. So we assume that at resonance IT equal to IR. As we know, the voltage across the load is 10 volt. So if we calculate the phase difference, the formula is T2 minus T1 equal to 0 second. So the phasor is 0. Then we calculate the active power, P equal to VI cos theta. And then we got 12.74 watt. Then we calculate the reactive power, Q equal to VI sin theta. So we got the value 0 VAR. Next, ampere factor, ampere power, S equal to VI. Then V is 10 and I is 1.274, and we got 12.74 VA. Then we calculate we calculate the power factor. Formula of power factor is active power over apparent power. So we got the power factor is 1.
Okay, my name is Manshorsamsudin. Okay, this is our simulation for this assignment. As we can see, we set the frequency at 1.25 megahertz and the amplitude is 10 VP. Okay, as we can see here, after we run it, we got the measurement is 1.272 for the IR. Okay, this is for the IL measurement. As we can see here, we got 12.384 milliampere. Okay, this is our measurement for the IT. As we can see here, we got 1.252 ampere. Okay, this is our and lastly, this is the last simulation to measure the power. Okay, as we can see here, we got 6.369 watt of the power and the power factor is 1. Okay, some of the measurement result we get here is not same with the calculation because there will be some factors that will affect the result, such as parallel error and something like that. Okay.